Hello and welcome back. In the previous video, I showed you how to bring up a Kubernetes cluster from scratch. And I'm going to show you how we can deploy Kubernetes Multicluster across 2 or more ACI Fabric enabling multi-geo application and disaster recovery. As a quick reminder, in order to do this, we're going to use KubeFedV2 to coordinate the configuration of multiple Kubernetes cluster from a single set of API in a, let's call it, controller cluster. Our topology is going to be pretty simple. We're going to have two ACI Fabric called Site 1 and Site 2. Inside these two ACI Fabric, we have two Kubernetes clusters already up and running that they are going to handle our workload. And then in Site 1, we also have a Kube Federation control cluster. This cluster will be the one that needs to talk with the Kube APIs of the cluster in Site 1, as well as the cluster in Site 2. And we're going to use multi-site to stretch connectivity across site for this communication. We're also then going to take a look at how we can configure our Kubernetes cluster to use external DNS to dynamically update the IP address of our exposed services into my lab bind DNS server. Let's now take a quick look at our starting point. I have two ACI Fabric, Fabric 1 and Fabric 2. And inside these two ACI Fabric, I've deployed my cluster. In Fabric 1, as I was showing you in the picture, I have my worker cluster called C1F1, and I have my Kube Federation controller cluster called C2F1. Here I just gave my application profile an alias to make it a bit easier to identify. And then in Fabric 2, I also have a cluster 1 from Fabric 2. The Kube Federation control plane pod are going to run inside our cluster 2 Fabric 1 cluster. So I'm going to create a new application EPG for KubeFed. I'm going to map this application EPG to our cluster 2 Fabric 1 pod BD. And I'm going to use contract master to inherit the same contract that are used by ACI container default. This is convenient, so I don't have to add manually all the basic contract like DNS, ICMP, and Istio that are all required for my cluster to work. However, KubeFed will also need to be able to talk with our Kube API, so to the inherited contract, we also need to add our Kube API contract as a consumer. So we're just going to add one last contract, and it's going to be the Kube API for our cluster number 2. And lastly, I'm going to add a VMM domain association for our cluster 2 Fabric 1. So now what we need to do is to use Multisite Orchestrator to provide connectivity between the containers node EPG of Fabric 2 and the containers node EPG of Kube Federation controller cluster, as well as cluster 1 Fabric 1. From a multi-site perspective, we only really need to import a handful of objects. The first thing we need to import is obviously the tenant that is already pre-existing. We can import it from any of the sites, it doesn't really matter. Just remember that once you have successfully imported, you want to go on the tenant itself and assign it to all your sites. Once the tenant has been created, we can proceed to the creation of our schema. Let's add a schema and let's call it KubeFed. And then in this schema, I'm going to add 3 templates. A common template mapped to our multi-cluster tenant, a Site 1 template mapped to our multi-cluster tenant, and a Site 2 template mapped to our multi-cluster tenant. Now we can start to import the required object. In the common template, we basically need to import only our VRF. We can import it from, again, any of the sites. Just select the VRF, hit import, and just remember to map then the common template to both sides. Now that we have imported our VRF, we also need to create a contract to allow the Kube Federation API to talk with our nodes. So we're going to create a new filter called KubeFed. We are going to add 2 entries. I'm always going to add an ICMP one. It just makes things a bit easier when we are testing. And then I'm also going to add our Kube API. Our Kube API port is 8443 as we created it before. And then we're going to create a new contract called KubeFed and map it to our filter. Now we can proceed and import the objects that are specific to each site. Let's start with the Fabric one. So here we are going to import the required EPG. So what EPG we need? We need our node EPG from both clusters, and we also need our Kube Federation EPG that we just created. Now for all these three EPG, we are going to disable include relationship. Then we are also going to import our bridge domain. So here we need both node as well as pod for our KubeFed cluster. And again, we disable relationship. And lastly, we import also our L3 out. We are not importing the relationship because most of the objects are going to be managed directly by ACI CNI, and importing them into Multisite Orchestrator could result in object going out of sync. Now we need to fix up a bit this configuration, nothing major. Onto the EPG, we just need to map that to the BD. So here we are on cluster 1 Fabric 1 node. So we need to pick cluster 1 Fabric 1 node. And then we do the same for cluster 2 Fabric 1 node and cluster 2 Fabric 1 pod. And then for the bridge domain, we are also going to map them to the VRF. And our L3 out is also going to be mapped to the VRF. We can now go into the site-specific configuration, and in here, the only thing we need to do is map our bridge domain to the L3 out. This is needed so our subnet are going to still be advertised outside of the ACI Fabric. And then we are going to repeat the same for Fabric 2. I'm not going to show you this just to save some time. Now, once we have imported also the object in Fabric 2, the other thing we want to do is provide our Kube Federation contract from our Fabric 2. And from Fabric 1, our cluster 1 is also going to provide Kube Federation contract. And then both the node and KubeFed EPG of our Kube Federation controller cluster is going to consume the Kube Federation contract. Now we can deploy this configuration to all our sites. And assuming there are no mistakes, we should now have cross-cluster communication via MSO. Now that we have connectivity between all our clusters, we want to configure our Kube Federation controller to be able to use kubectl against both of our worker clusters. In order to do that, the simple way is to create a new kubeconfig file containing the detail on how to access our cluster. Now the file, it's a bit tricky if you never did it, but it's basically contain a list of clusters. So in this case, I have two, cluster 1 Fabric 1 and cluster 1 Fabric 2. You then define the context, that is basically a way to map a cluster to a user. And then we define the user. So here we have one username called cluster 1 Fabric 1 admin and another one called cluster 1 Fabric 2 admin. And then depending on which context you're going to pick, you're going to use a specific combination of cluster and username. Now, where do we find the certificate authority data and the client certificate data and the client key data? Inside this file. Each cluster will have this file, and if you basically open it up, it will have the data that you then need to copy and put inside here. Once you've created this file, to test it, it's pretty easy. You can use this command to set what is your default context to use. So here I'm saying use as default context cluster 1 Fabric 2. We can now use our standard command to check the status of this cluster. For example, you can do a get node, and now you will see that we are accessing cluster 1 Fabric 2. If we want to switch to use the other cluster, we can simply do this. We will switch to a different context. And now we can reissue the same command, and you will see that we will now be getting the status of the nodes for this other cluster. Now that the two clusters are added into our configuration file, the next step would be to add our KubeFederation control cluster and then replace the config file into your home folder .kube directory, so that now without having to specify any option, with the kubectl command, you can access all of the 3 clusters. Now that cross-cluster authentication is configured, we can install KubeFederation. KubeFederation is installed via an Helm chart. As of today, KubeFed supports only Helm 2. So now we're going to install Helm version 2.16.9. We're going to get an installation script. We're going to allow execution of it. And now we're going to simply execute it to install Helm 2.16.9. Next, we need to configure role-based access control for our Helm Tiller service account. And now we can init Helm. And in a few seconds, we should have a Tiller deploy pod up and running. Now we can create our KubeFederation system namespace. KubeFed will actually look for this exact namespace, so it's easier to just use this one, so we don't have to modify anything else afterward. And now we can annotate it so that it's gonna be placed into the KubeFed EPG that we have created on our ACI Fabric. And now we can double check with the describe that indeed the annotation is present. Now we can add our Helm repo and we can install our chart. Once the deployment is complete, we can then take a look into our ACI Fabric to check if the pods are appearing. The last step is to install our KubeFed control command. This can be installed with this script. And lastly, we can now join our clusters. Now, how do we join the cluster is by executing a command like fed control join and then the cluster context name. Now, what is the context name? Is what we have defined into our kubeconfig. And the name of our context are C1F1 admin and C2F1 admin. So let's try. Now I'll do the same for my second cluster. And now we can check if our clusters are joined successfully. And so they are. So now you can see we have both clusters joined together, and now our KubeFederation controller pod are talking with the Kube API of both clusters. And now, if we want, we could say kubectl use context, say cluster 1 fabric 2. And if we do now a kubectl get NS, you will see that we're going to have a new namespace called KubeFederation system that was not present before into this cluster. Now that our cluster have joined our KubeFederation system, let's try to deploy something. So first of all, let's ensure on the controller cluster we are going to actually use the controller context. These two below are my cluster 1 fabric 1 and cluster 1 fabric 2. Now let's get one application that we can use for our test. So we can just use the classic guestbook. And now we can use the KubeFedCutl command to convert this configuration into a federated one. So this will basically prepare it, and if we take a look, you will see that it has all the resources converted into type federated services, federated deployment, and so on. Now we can create our namespace. Now this is where the power of federation comes into play. We can run this command now, and what this command is basically doing is that it's creating a namespace called guestbook, but then it's also creating a federated namespace resource. And then it's going to specify that I want to federate the resources inside this namespace to my cluster 1 fabric 1 admin and cluster 1 fabric 2 admin. These are the names of my cluster. Now that I've done that, you will see that the namespace is present on all my 3 clusters. So it's present on my control cluster, as well as on my first and second cluster. Now, the cool part is that when we go and we actually deploy our configuration, what is actually going to happen is that these resources will only be created on the cluster that we federated the namespace to. So if I run again my get pod, you will see that on my controller cluster there is nothing running. But if we do the same command on my fabric 1 cluster and on my fabric 2 cluster, here you go. Now we have brought up 2 independent guestbook applications by deploying it against my controller cluster. However, we will have federated resources. So if you see here, we have federated services. So now what we can do is that we can edit our federated service, for example, front end, and change its type from node port to load balancer. And the moment we do that, if we check again on our cluster, now we have exposed the service with an external IP address. And this is all happening like seamlessly, and now the services will be accessible directly from both of our ACI Fabric. Now the next step is to configure external DNS to push these IP addresses into my DNS server. But even before we configure external DNS, there are a few steps we have to take. KubeFed has a feature called MultiCluster Service DNS. This feature provides the ability to manage DNS resource records of type service and ingress of objects across the cluster. What it means, put simply, is that KubeFed creates for us a nice mapping between our external IP and a fully qualified domain name. In this demo, I'm going to work mainly with services, but it works very similarly for ingress resources as well. As you can see in the picture, we can create a service DNS record object to inform the service DNS controller to look for specific services in our clusters. Once these services are created with an external IP, the DNS endpoint controller will then populate the DNS endpoint object that is then read by external DNS to update our bind DNS servers in the lab. Now let me show you how we can configure all of this. First thing we need to do is to label all our nodes into our cluster by specifying a region and a zone. So as region I put Australia, and then as a zone I put the name of my ACI Fabric. So this is Fabric 2, so I'm going to put Fab2. And then I'm going to repeat the same for my other set of nodes connected to Fab1. This is a must because MultiCluster Service DNS will actually use the region and zone label to create your DNS record, and I'll show you after how this record looks like. Once our node have been labeled, the next step consists in creating a domain object that associates a DNS zone and authoritative name server for the KubeFed control plane. We are going to call it MCS DNS. Now be careful, this name is actually going to be part of your DNS name, so do not go crazy. And this domain has to be placed inside the namespace where the KubeFed controller manager is running. So in my case, it's Kube Federation System. And then I'm going to tell him in which subdomain in my external DNS provider I want to add this domain. So my external DNS domain is kubernetes.mso, and then we're going to add a subdomain called MCS DNS into it. Then for every service that we want to push into our external DNS server, we are going to create a service DNS record. Now the name of the service DNS record is very important because this name here must match to the name of the federated service that you are exposing. So if now we go and we apply this configuration file, we should have now created a domain and a service DNS record. Now we can check that the domain is created correctly. And then if the domain is present, now inside our guestbook namespace, we should have a new object of type service DNS record. And you can see that our service DNS record, it's already mapped to two of our external IP. You will see that we are using an IP of type load balancer with this IP in region AU in zone Fab1 because this guy runs on my cluster 1 Fabric 1. And then on cluster 1 Fabric 2, we're going to have the same, but now the IP address of our service is just different, and the region is AU and the zone is Fab2. If now we check the content of the DNS endpoint object, you can see that it has been populated with 4 DNS names. You have a generic one that is basically saying if you are trying to reach the front-end service of the guestbook app inside our multi-cluster DNS system, you can try these 2 IP addresses. And these 2 IP addresses maps to the exposed services of my ACI Fabric 1 and ACI Fabric 2. However, if you are looking at specific services running on Fab2 in Australia, then is 16. And if it's Fab1 in Australia, then it's 103.15. Now that this part works, the last step is to deploy our external DNS. This is really easy now. All we need to do is to create a few cluster role, service account, and cluster role binding to allow the external DNS pod to write and read the resources that it needs to have access to. And then once our role-based access control is configured, we are gonna define the deployment where we're basically saying run external DNS. Here I'm using an image provided by Bitnami. And then we're gonna pass some option to our external DNS. The most important one are obviously the fact that we are running bind. So we specify the provider to be RFC 2136. We specify the parameter for the provider. So basically, which one is the IP address of my DNS server, the port, the zone that we wanna use, and so on. And then, very important, we also gonna tell external DNS has to work with multi-cluster DNS. So we're gonna specify that the source is a customer source definition. The customer source definition API that we're gonna look for is the multi-cluster DNS one, and specifically we are gonna keep an eye on the DNS endpoint. So now we can go and apply this configuration. And this will now spin up our external DNS pod. And now if I didn't do any mistake, we should be able to just do a DNS lookup for the specific domains. And there you go. We get the specific services advertised in our DNS server. If now I do the same, but for my services exposed in my Fabric 2 in Australia, now I'm gonna get as a reply only 10.230.16. So I hope this makes sense, and it shows really how easy and powerful it is to use Cisco ACI MultiSite with KubeFederated and External DNS to deploy a Kubernetes multi-cluster environment across 2 or more ACI Fabric. Currently, the integration with ACI CNI and KubeFed is a tech preview. In the future, we also plan to automate the configuration of Multisite Orchestrator. If you want to use it already today, please reach out to containers@cisco.com so we can help you. Thank you for watching, and stay tuned for more video in the future.